Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7. Would like to present our slide presentation, which is the title is Construction as a Manufacturing Process Lesson from the Automotive Industry. Before that, I would like to introduce to all of you our group members.
Hello, my name is Adi Maiswa Flabi Azlan.
Assalamualaikum. My name is Muhammad Azman bin Abu Bakar and I am from 3BNG.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syafiqah Rukaya binti Saiful Azam.
And my name is Muhammad Amirul Rahman bin Azhar.
So, next slide is introduction. So, the objective of the paper is to show how the construction can and should be viewed as a manufacturing process. So at first glance, the automotive industry may appear to be far removed from construction, but its influence on society goes far beyond the manufacturing. So its revolutions change our most fundamental ideas on how we make things. So these changes have influenced that the way we work, what we buy, how we think, and ultimately the way we live. So next slide is the definition of the manufacturing. So the definition of manufacturing by Chris Solares is the process of transforming and material and information into goods for the satisfaction of human needs. And the second one is the definition of from Laningan, which is the application of technology to wealth creation by providing cost-effective solution to human needs and also problems. So for the next slide is the rise of mass production. So it is like a history how it rise. So first Henry Ford who applied and extend the Taylor philosophy of scientific management to the mass production of the automobile. Then in World War I, Henry Ford and Alfred Sloan of General Motors moved manufacturing from centuries of European dominated craft production into the age of US dominated global mass production. So in World War II, E.G. Toyota and Taichi Ohno at the Toyota Motor Company in Japan pioneered the concept of lean production, as other Japanese companies copy this system. Japan quickly rose to its current economic preeminence. And then the first industrial revolution is at 170s act as turning point to this improvement, which is the development of better engineering material. Second one is the application of mechanical power. The third one is the development of new tools suitable for mechanism like turning, milling, and grinding. So the fourth one is the application of precision measurement, and the last one is the elimination of fitting due to interchangeability of parts. Okay, so for the next slide is the trouble with mass production. So there are two trouble. So in 1980s, limitation and inflexibility of traditional mass production reduced the competitiveness of Western motor manufacturers and preventing them from meeting the needs of an even more demand customer. So the next is Taylor Ford system. assumption of independence and separability in a complex manufacturing operation is also a faulty. That's it.
Now I would like to explain about the improving the manufacturing process. There are three significant for improving the manufacturing process. Which is the first is quality system, second planning and scheduling system, and the last one is manufacturing system. Uh, for quality system, there are three uh, concepts. First is SQC, statistical quality control. Second, TQC, total quality control. And third is TQM, total quality management. For planning and scheduling system, there are also three concepts. First is MRP2, Manufacturing Resource Planning. OPT, Optimized Production Technology, and JIT, Just in Time. For manufacturing system, uh, there are four concepts. First is GT, Group Technology, Cellular Manufacturing, FMS, Flexible Manufacturing System, and the last one is CIM, Computer Integrated Manufacturing. Computer Integrated Manufacturing. The application of computer science technology to the enterprise of manufacturing in order to provide the right information to the right place at the same time, which enable the achievement of its product, process, and business goal. It is impossible to convert an tradition tolerance plus minus for this manufacturing plant to CIM by simply installing sophisticated new equipment or incremental additions to existing software. Ayres has proposed that a new type of non-hierarchical network organization with distributed intelligence and decentralized decision-making powers is evolving. Lean production. I will take an example, the reason for the success of the Japanese car industry. In Japan, lean production combines the advantage of craft and mass production while avoiding the high cost of the former and the rigidity of the latter. Lean production philosophy states that there are only two aspects of production system that are important, which is conversion activities and flows. Business process re-engineering. It is used for the examination and redesign of all aspects of company operations, be from product design and manufacture to order fulfillment, be to make them more efficient. Most attempts at re-engineering have ended in failure because many consultants treat re-engineering as a cure-all for every ailment, ignoring the human side of management, sacrificing such intangible goods as commitment and creativity to short-term efficiency.
Okay, so we proceed to relevance of the construction industry. Why it is relevance? So we may now ask what the construction industry can we learn from the transformation of manufacturing. So the first phase is CIM steel. The traditional market for number of large construction has fallen and they suffer huge loss. You also face a period of dramatic restructuring in order to adapt to new market environment. So, in order to adapt, they recognize that they need to improve of manufacturing process, which is for construction. that both require harmonization and also optimization of efficiency and productivity using advanced computer technology. So the ideas of Le Corbusier and others are resulting a new method which is strongly influenced for design and construction philosophy into the 1960s system building. So the three main principles that underpin for industrial construction is standardization, which is building component for a prerequisite for production under factory conditions. So the second is prefabrication, which is together with dimensional coordination, and third is system building to enable the growth. The next, the computer integrated construction can be applied in order to be viewed as formation processing industry. In fact, the use of computer that is easy to use and software had brought us to the point where all the construction process is influenced by IT. Then the most effective or cost effective is to create and manipulate the engineering information in digital form in order to increase the liquidity in process and make sure that the growing pressure are more suited to management for digital information and related computer system. So what is the real lesson from the automotive industry that we can conclude? So the failure of Taylorism was due to inappropriate or incomplete application of the theory. Then they need to improve the existing process to make assembly line more efficient. The third is they having a overcapacity. They grown to almost 80 million vehicles a year, while demand will have risen to 60 million. So they make overcapacity car than the demand. So then they comparing the profit margin. A little difference in average is declared as pre-tax profit. So the profit margin is in manufacturing is insignificant while compared to the growing sector of industry. So the increasingly car makers earn better profit from financial car sales or lease than from the car themselves.
Okay, for now I would like to continue for the misunderstanding construction industry. First, the construction industry has been slow to adapt to technology change and remains largely labor intense and user of flow technology. Secondly, to approach to the evolution of a craft-based industry in manufacturing industry, firstly building technique change, and secondly is make the production process as flexible as allowing a larger variety of building to make up a small number of standard components. The third point is move to manufacturing, which is not mass production. For the fourth, the concept of assembly, decomposition are of fundamental importance when planning the construction of building. Next, knowledge and control of the process of manufacturing and assembly, which are seen as the key of high productivity and low cost. Lastly, knowledge must be harnessed and brought forward to help the upstream design activities. For the second point, for the next slide is future trend. Okay, for the next slide, future trend in construction. The trend toward design building increase to the point where it's become the norm. The main contractor will become the lead producer of building or other construction product. From the slide we can see three photos, which is 3D model are created and combined with all building data, and secondly the owning, and thirdly is design and client can preview building and mode change before construction. For the conclusion, first, the outer draw is the corporate profitability has little to do the efficiency of production. Second, we can improve productivity quickly. Be sure that our competitor have improved their productivity too. Thirdly, capital have done a great deal to speed up the existing process, but they are not a finisher of the poor productivity. And fourth, the future profitability of the construction industry does not lie in any single innovative and technology or manufacturing technique. And the last one is, if applied correctly and approximately to the construction industry, the lean production philosophy will allow the integration of the internal process. Okay, I think that's all from us. Thank you.